Okay, welcome back. And today we're going to start talking about applications of Venn diagrams, section 2 of chapter 7. So now, again, this is a Venn diagram, and we're looking at the relationship between two sets. Notice that if we have one set, then we have two regions to consider. Things inside the circle and things outside the circle. Okay, so again, the numbering is arbitrary. This could have been easily set 1 and this region, or region 1 and region 2. So again, the numbering is arbitrary. Okay, if we have two sets, then look how many regions we have. We end up having 4 regions. Okay, now if we have two sets this way, well, we end up with 3 regions, right? So if there's overlap, we end up with another region, the intersection here. And then if we have this set, then we still have 3 regions. We have the concentric circles, if you will, and the universal set. Okay. So again, depending on how the circles are oriented, will give us a certain number of regions. So now in this example, we want to draw a Venn diagram that represents the following sets. So we want to draw a Venn diagram, and then we're going to shade the region that represents all the elements that are not in A and in B. And that would be this one. So all the elements that are not in A, so outside this circle, and in B. So outside the circle would be all of this. But now the intersection is, we want the intersection of everything that's not in A and in B. So the intersection is going to be this shaded region right here. Okay. If we just said not A, it would be everything outside the circle, okay, including everything else in the universe, in the universal set. Now, what about this one? It says the union of not A and not B. So this means not A or not B. So we want everything that's not in A or not in B or both. Okay, so we want the union of these two sets. Okay, so everything outside of A and everything outside of B we're going to put together and get rid of the duplicates. Okay, so notice that we got everything except the intersection. So if we say not A or not B, then that's the same as saying not in A and B. Okay, but again, if you just think about it, not A, right? Everything that's not in A or not in B or not in both. Okay, and so if we do that, we're going to get everything except for the intersection. Again, draw these diagrams yourself and from scratch and show yourself that this is true. Prove it to yourself. Now it says here, draw a Venn diagram and shade the region representing the area, the set that represents A or not B. A union, not B. So A or not B. So we want everything in A or not in B or both. Okay, not both A and not B. And then we'll get rid of the duplicates. So we're pooling everything together. And so the set not B contains all the elements outside of B. So outside of the circle. Okay. So to find the union of these two, we're going to identify the region represents the set. So identify the region that represents the set of all elements in A. That's going to be this. Okay. not in B, that's going to be everything outside of the circle, so or both, which is the intersection, or excuse me, both A and not B. So A and not B is going to be this circle here, or excuse me, this piece right here, this little moon piece right here. Okay, and we're going to put all those regions together. So everything outside of B, that includes everything outside of the circle, and then we're going to take everything in A, and then everything in the intersection of A and not B, which is this one. So there's a lot of double counting. So we're going to pull all those together, and we're going to get this shaded region here. Now, if we have 3 overlapping circles like shown in here, we end up with 8 regions. Okay, so what we're going to do is when we have 8 regions, or it doesn't really matter, but when we have a certain number of regions, one of the things we want to do is answer questions about, hey, if we know we have like 500 objects, one of the things we want to do is figure out how many of those objects fall within each one of these regions. And we can do that by just critical thinking and using the information that's given to us and understanding how the Venn diagram works. Okay, so here's an example. In a Venn diagram, shade the region that represents not A and the union of the quantity B and not C. So again, we're going to start with the intersection and then work our way out. Okay. So what we need to do is we first set up our Venn diagram. Okay, and again, the numbering is arbitrary, but what we do is we first start with this. We want B and not C. Well, B is right here. Not C is everything outside of the circle. So the intersection of everything that's outside of C and everything that's inside of B is going to be this half moon area right in here. Okay, so everything inside there is this piece right here. Okay, so now this is the piece we're going to look at. Now we're going to take this piece and we're going to union with it with not A. So we're going to take this piece right here and we're going to union it with everything that's outside of A. So we're going to take everything that's outside of A and this piece of B and just pull them together. Well, that gives us everything outside of A and then this little piece right here. Okay, because this is already counted. Okay, and of course everything else is outside of A. Now here it says draw a Venn diagram and shade the region representing this set. Now again, look at this here. We're going to do this piece here first. We want the B union C. Okay, B union C. So that's going to be both of those circles together. Okay, so B union C is going to be this circle and C. So basically shade in all of C and all of B. That's going to be this piece right here. And then we're going to intersect that with not A. So we want only that piece that is the intersection of B union C and not A. So we want everything outside of A, the intersection of everything outside of A and B union C. Well, the only piece that does that is this shaded region here, everything in here. Okay. Now let's start putting some of this stuff together. So it says example 3. Now we're going to have some numbers. It says a researcher collected data on 100 households and finds that 76 have a DVD player. It should be 21 have a Blu-ray player. 12 have both. So A, how many do not have a DVD player? B, how many have neither a DVD player nor a Blu-ray player? Well, if we look at how many people do not have a DVD, that would be outside the circle of people that do. Okay. How many do not have a DVD player? Okay. So the first thing we're going to need to do is we need to fill in our Venn diagram. So the first thing we're going to do is we're going to draw a box with our universal set and then put in the two circles overlapping. Okay. Now, and we're going to use this information. So we know that 12 have both. So we always start with the intersection piece first. So we know 12 has to be this number. And then what we're going to do is we're going to use the other information and the fact that they're 12 in both to get the rest. So we know 76 have a DVD player. Well, if 76 have a DVD player, that means 76 has to be this total circle. Now we know 12 is here, which means how many is left over for outside? Well, it's going to be 76 minus the 12, which gives us 64. And then we're going to take the other piece of information about the 21 Blu-ray players, right? That 21 people have a Blu-ray player. And we know, again, over here, that this circle should be 21. So these two numbers, these two regions, rather, should add up to 21. So if we know that there's 12 here, then we subtract, and we find out that there's 9 outside here. Okay, so now watch what happens. Now we can add all three of these regions. Okay, so we add 64 plus 12, which gives us 76, plus 9, which gives us 85. Well, where's the other 15? Well, the other 15 has to be in the final region, the outside region, which we put right here, 15. Okay, so we start with the intersection, and then we use the other information and subtract off 12 to get the other pieces, and then we add these three regions and subtract from the total, which should be add up to 100. So if you add up all four regions, you get your 100 people. Okay. Now, look at this example. A survey of 75 freshman business students at a large university produced the following information. 25 of the students read Bloomberg Business Week. 19 read the Wall Street Journal. 27 do not read Fortune. 11 read Bloomberg Business Week, but not the Wall Street Journal. 11 read the Wall Street Journal and Fortune. 13 read Bloomberg Business Week and Fortune. 9 read all of them. Okay, so now we're going to use this information to fill out our Venn diagram, but we got to write the Venn diagram first. So we're going to have 3 overlapping circles. Okay, so we're going to have 8 regions to fill in. Now these are the questions we want to answer. How many students read none of the publications? How many read only Fortune? How many read Bloomberg Business Week and the Wall Street Journal, but not Fortune? Okay, so let's answer these separately. So it says, how many students read none of the publications? Well, we start with the intersection, right? So we know 9 read all 3. So that means whatever this intersection is, we're going to subtract 9 to get this one. Whatever this is, we're going to subtract off 9 to get this one. And whatever this intersection is, we're going to subtract off 9 to get 5. Okay? So now, we know 9 read all 3. There's our middle intersection. So we know that 13 read both Bloomberg and Fortune. So Bloomberg, where is it? It's right here. Bloomberg, Fortune. So this is 13, right? The and. 9, so 13 minus 9 gives us 4. So there's the 4. Let's see. Here it says 11 read the Wall Street Journal and Fortune. Okay. 11 read the Wall Street Journal and Fortune. So the Wall Street Journal and Fortune. So here's the 11 right here. Subtract off 9, that gives us 2. Okay, so now we've got these 3 pieces right here. Okay, so now we know that these 3 regions add up to 15. Okay, so let's go back. Now, so Fortune, okay, does it say anything about Fortune? Let's see here. See what else we can read. Okay, so 19 read the Wall Street Journal. 25 read Bloomberg Business Week. So 25 read Bloomberg Business Week. So we know, well, let's see, how can we do this? We've got these 3. Let's go back. So we got Bloomberg in here, Wall Street Journal in here. Oh, here. 11 read Bloomberg, but not the Wall Street Journal. Bloomberg, but not the Wall Street Journal. So Bloomberg, but not the Wall Street Journal. Okay, so that means here. So how many is that? 11. So this piece right here has to add up to 11, which means this is 4, we already got. We already got these 3, but now 11 minus 4 is 7. So that means this piece right here is 7. Okay, so now, guess what? Now we can get this piece here because how many people read Business Week? 25. So that means all of these 4 regions here have to add up to 25. Well, we've got these 3. This gives us what? 20, which means this has to be 5. So now we've got these regions and this one. So the only ones we need is 3 more regions. Okay. Okay, so let's see what else we got. So we've got 27 do not read Fortune. So 25 do not read Fortune. So that means these 4 regions have to add up to 25. Well, we know this one. Oh, hold on a second. Oh, go back. The Wall Street Journal. Hold on. 11 read. Where's the Wall Street Journal? Oh, 19 read the Wall Street Journal. There we go. We got that one. So 19 read the Wall Street Journal. Well, we got these 3, right? So this is 16, which means 3 has to be in here. Okay. Now, what else? Let's see, we got so 27 do not read Fortune, and we got 11 read Bloomberg, but not the Wall Street Journal. Bloomberg, but not the Wall Street Journal. Yeah, we already did that one. We already did that one. So the last one is going to be this one. 27 do not read Fortune. And that's the last piece we need. So 25 do not, oops, hold on. 27 do not read Fortune. So we've got all of these, right? We know 27 do not read Fortune. 27 do not read Fortune. So guess what? That means we got these 3 pieces right here. So outside of fortune should add up to 27. So this plus this plus this plus the outside, which we don't know, has to add up to 27. Well, we know these, so this is 15. Well, 15 minus 27 minus 15 is 12, so we know 12 has to be out here. Well, guess what? Now we can figure out fortune because all the other regions have to add up to 100. Okay, because that's what we're given. We're given 100 students, or we're chosen. So if we take all these numbers and subtract off from 100, we get 35, and we filled out the table. So now we can answer the question, these questions. So the first step is filling out our table. And so we're going to answer the first question by part A. So that's going to say, how many students read none of the publications? Well, obviously, now that we have the table filled out, it's easy. It's 12. 12 doesn't read any of them. B, how many read only fortune? Well, that would be this region right here, because that's fortune but none of the rest. So that's going to be 35. And C is how many read Bloomberg's Business Week and the Wall Street Journal but not fortune. So both of these but not these. So it's going to be Business Week and the Wall Street Journal. So that's going to be this intersection, but not fortune. So it's going to be this piece right here, 5. And that's how you do it. So the first step, the major step, the biggest step of doing this is setting up your Venn diagram. Once you set up the Venn diagram, answering questions like these becomes very easy. Okay, so in example 5, we have Jeff Friedman is a section chief for the electric utility company. The employees in his section cut down trees, climb poles, and splice wire. Friedman reported the following information to the management of utility. So this is what we know. So of the 100 employees in my section, he says 45 can cut down trees, 50 climb poles, 57 can splice wire, 22 can climb poles but cannot cut trees, 20 can climb poles and splice wire, 25 can cut trees and splice wire, okay, 14 can cut trees and splice wire but cannot climb poles. 9 cannot do any of the 3 management trainees. Okay, so this is the information. So we're going to use this information and what is going on here. So we have cut trees, climb poles, and splice wire. So those are going to be our 3 circles. And so what you're going to do is use this information to fill out the Venn diagram. Okay, again, 45 cut trees. Okay, so let's see, 45 cut trees and 25 cut trees and splice wire. 25 cut trees and splice wire. Let's see here. So we've got 20 climb poles and splice wire. 14 can cut trees and splice wire, but not climb poles. So we got 25 here, but 14 are here. Okay, so let's see what we can get with that. Oops. So 25 cut trees, splice wire. So there's a 25. Okay. But 14 can cut trees and splice wire, but not climb poles. So there's the 14, right? Not climb poles. So that means of the 25, 14 are here, which means 11 is here, right? So now we can figure out the rest of them because we know 20 can climb poles and splice wire. So we know that this is 20, and since 11 is here, 9 have to be here. Okay. And let's see here. What else can we get? Oh, well, since we know that 45 can cut trees. Hold on, let's see here. Oh, oops. Here. 22 can climb poles, but cannot climb trees. Climb poles, but cannot climb trees. Climb poles, but not cut down trees. Okay, so that's going to be these two. Okay, but since we know let's see. Hold on. Yeah. So we know 22 can climb poles but not cut trees. So that means 22 is right here, right? So we know 22 has to be these two, but since we know this is 9, that makes this 13. And now we can fill in this piece here, 17, because we know the total that can climb trees is 50. So we know that this plus this plus this plus this has to add up to 50. So this is 20, 33, and then 33 plus 17 is the 50. So we know that piece. Okay. Now, as far as cut trees, we know 45 can cut trees. So now we have these three numbers. We subtract this from the total, we get 3, right? And we know 57 can splice wire. And so now we know these three, and we can get this one. And then finally, we know that this is 9 because that's given to us. Okay. So now we can answer questions, any questions regarding the Venn diagram. Now, another rule for sets is for union. So it's called the union rule. Okay, this is going to come up again later in probability. So if we want, and the way this works is this little n out here means the number. So n of this set, it means the number of elements in this set is equal to the number of elements of set A plus the number of elements in set B minus the number of elements in the intersection, that is both in A and B. So remember, this is like an OR statement. So A or B, or A union B. So this is also known as the cardinality. So the cardinality of this set is equal to the cardinality of this set plus the cardinality of this set minus the cardinality of this set. Okay. So another way of saying is the number of elements in A or B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A and B. Okay, so the number of elements in the union is equal to the number of elements in each set added together minus the intersection. Why is that? Because if we're counting all of the elements in set A, and we're counting all the elements in set B, well, remember, in the general sense, these two sets could have an overlap, right? There could be an intersection. And so in that case, we would double count. There'd be some double counting going on. We'd be counting things twice. In other words, we'd be counting the overlap twice. So we have got to subtract off one of those. So that's where this the union rule of sets comes in. Okay. Now, if they're disjoint sets, remember, what's this? The intersection is the empty set, right? And what's the cardinality of the empty set? How many elements are in the empty set? 0. So it reduces to just the number of elements in this set plus the number of elements in this set. And if you remember, I keep saying this, that if when we're counting the union, we say, okay, we're saying it's either we're counting the elements in A plus counting the elements in B, and then we're getting rid of the duplicates. That's getting rid of the duplicates right here. Okay, and so this is the general case. And so when we count the number of elements in A, when we count the number of elements in B, we're counting this intersection piece twice, so we have to subtract off one of those. Okay, so now it says, a group of students are sitting in a lounge. All are texting or listening to music or both. 11 are listening to music and 15 are texting. 8 are doing both. How many students are in the lounge? So we work our way from the middle out. So we know that 15 are doing both, right? So what do? We add them and subtract off the intersection. add the numbers in each and subtract off the intersection. So we let A represent the set of texting students, let B represent the set of students listening to music, and then of course we're going to use the union rule. So the number in A is 15, the number in B is 11, and the number in both is 8. And so we're going to find the union, right? The number that is in one or the other or both. So we're going to use the union rule. So we get 15 plus 11 minus the 8, and we get 18. So there are 18 students in the lounge. It's that easy. Okay, so now using this table here, we want to use this table, and we have these three. So these are all the people that are or species that are endangered. These are all of the species that are threatened. So this represents one set. This represents another set. So E and T. Now, this row represents A, amphibians and reptiles. This represents a set of I, which is arachnids and insects, which are spiders and insects. Birds is set B, so this row represents birds. This represents crustaceans, so you're talking about clams, crustaceans, corals, and snails, right? And this represents fishes. This row represents mammals. Okay, so we got our totals. So we got our column totals right here. We got our row totals, and we got our total totals. Okay, so this is what we would call a contingency table. Okay, so now looking at these as different sets, we want to know what's the intersection of E and B. The intersection of E and B, well, what's in both E and B? Well, it's going to be the intersection. So what? The intersection of this row and this column. So guess what? The set of E and B is this set, which is 291. There's 291 species that are both endangered and birds, or there's 291 endangered birds. Okay. Now, what about E union B? Well, E union B means we want to take the union rule, right? So we want to add all of the elements in E plus the elements in B, and then subtract off what's in both. Okay, so E. So these are going to be the totals, right? E is, we're going to use the column total. So that's going to be 1,050. Then we're going to use the row total here for birds. That's going to be 324. Okay, so we're going to add those, and we get what? 1374. Okay, now we're going to subtract off the union because there's double counting going on, right? Which is going to be this one, right? So we're going to subtract off the 291. So what do we get? We get 1374 minus 200, which is 1174, okay, minus 100, right, which is 1074 plus 9, which is what? 1083. And so we know that there's 1,083 species, distinct species, that is in either this one or both. Okay. And what about this one? This is taking the union of these two and not in this one. So let's do the union of these two. So we're going to use the union rule, F and M. Well, we're talking fishes and mammals. Now, are those distinct, or is there any overlap to these? Well, no, because these are two different categories, right? These are two different, what's the word? Oh, not species. These are two different, is it phylum? Ooh, I gotta think. It's not kingdoms. Is it kingdoms? No, it's not kingdoms. It's phyla. I think it's phylum. So there's 5 different phylums. There's mammals, fishes, reptiles, amphibians, and then you have your, oh my gosh, plants. Okay, so no, that's fine. Anyway, oh, I got to go back and read. So we've got these endangered species, threatened endangered. So are these different species? I guess they would be. Well, that's yeah. This is not species. So anyway, I'm digressing. So these are different groups. If you're a mammal, you can't be a fish. These are two separate groups, distinct groups. Okay, so there's absolutely no overlap. Okay, between fishes and mammals, you can only be either a mammal or a fish. You can't be both. Okay, by definition. By definition of a fish, you cannot be a mammal. Okay, because there are characteristics that exclude you from being both. Okay. For example, mammals have lungs. Fish do not have lungs. So in order to be a mammal, you must have lungs. So fish are automatically disqualified. But now there are fish that have quote unquote lungs, but again, there's other things that disqualify. Um, so again, if you don't remember, mammals are warm-blooded. They have hair. They give live birth. They are warm-blooded. Did I say warm-blooded? Yeah, I think I said warm-blooded. Warm-blooded, and they also what is it? There are 5 things. Oh, and feed their young with milk. So, ta-da! So, and they breathe the air through lungs. So that's it. So now these are distinct. So guess what? All we have to do is to find the union of these two is add up these two numbers because these are the row totals, right? And so there's no intersection between the two. So that's it. So this would be 530. Okay, so there are 530 altogether that are either in the category of fishes and the category, either the category of fishes or the category of mammals. So now 530, now we want to take the intersection of that 530 with those that are not threatened. Okay, well, not threatened means what? Endangered. Okay, or no, hold on. Yes, yes, endangered. So we want the ones that are endangered. So not threatened means that they're endangered. So we want the intersection of the 530, these, right, these 530, and now of endangered. So what's the intersection of these? So which ones are both in either one of these, and endangered? Well, that would be these two numbers. Okay, so the union of these is 530. So of those 530, how many are endangered? Well, that would be this number here, which would give us what? This would give us 430. Okay, and so that would be the answer. Okay, so now here's the last example. Example 8 says, suppose a group of 150 students have done at least one of these activities online: purchasing an item, banking, and watching a video. In addition, we know that 90 students have made an online purchase, 50 students have banked online, 70 students have watched an online video, 15 students have made an online purchase and watched an online video, 12 have banked online and watched an online video, 10 students have done all three. How many students have made an online purchase and banked online? Well, guess what we're going to have to do? We're going to have to take these three categories of activities and create a Venn diagram. So we'll have a circle for online purchases, we'll have a circle for banking online, and we'll have a circle for watching an online video. And then we're going to fill in the numbers. And so when you fill in the numbers, what are we looking for? We're looking for how many students have made an online purchase and banked online. So both of those. How many students have made an online purchase and banked online? So made an online purchase and banked online. So what happens is when we fill in the information, we don't get a full picture. For example, we don't know what this is. Okay, we don't know what this is, and we don't know what this is. Okay, but we do know some of the information that we're given. So we know that 90 students have made a purchase online. Okay, let's start with the intersection. Okay, so we know 10 has done all three. So we know this one is 10. And then we work backwards. We know 12 have done banking and watched an online video. Banking and watched an online video. Okay, so these two. So now that we know this is 10, we know this has to be 5. We also know that, let's see here. We know 15 have made an online purchase and watched an online video. 12. I'm sorry, 12 banked online and watched an online video. So these are these two. Banking and watching an online video. So these two. Okay. And then the other one gives us these two. So we know these three already. Now, we can find this one because we know that there are a total of 70 who have watched an online video. So now we can add these three regions and then subtract from 70. So this adds up to what? 17. 17 minus 70 is 53. So now we know these 4 regions. Okay, now, what else do we know? Well, with these 2 pieces of information, well, what do we know? Okay, so we know 50 students have banked online. 50 students have banked online. So we know these two, right? So again, which one we make the X doesn't really matter. But since this one here is mixed with both of them, we'll make this one the X. It'll make our calculations easier. If we make this one the X, then we'll have something going on over here that'll look a little bit more complicated. So here, since this is the piece that's in common in both, let's make this the X. And then this is going to be whatever left over minus X. So what's going on here? So if we talk about banking, we know that 50 people have done online banking. So we know this plus this is 12. So we know 50 minus 12 is 38. So we know if this is X, then this has to be 38 minus the X, because both of these have to add up to what? 38, which they do. 38 minus X plus X equals 38. Okay? And then likewise over here, we know this has to add up to 75, or excuse me, not 75, to 90. Okay, so 90 students made an online purchase. So we know this plus this is 15 minus the 90 gives us the 75. So we know this piece here has to add up to 75, and it does. 75 minus X plus X equals 75. Okay, so now this is what we have to solve. Okay, now, in this case here, we have 150 students. Right? So now, what do we know? So we got 90. Is there any other information here that we can use? Okay, well, in this case here, we've got X we have to figure out. Okay, so we know, what do we know? We know that all of the regions have to add up to 150. Okay, so what we get is we get this plus this plus this, so we get 53. So 53 plus 7 is 60, plus 10 is 70. And then 70, let's see here. Can we solve this? I don't know if we can solve this. So this has to add it to... And let's see, minus this. We don't know the outside yet. Oh, wait a minute. Oh, wait a minute. Maybe we do. It says, suppose 150 students have done at least one. Ah, we do know. Because the outside has to be 0. Because we're saying 150 students did at least one of those activities. So guess what? The number of students that did none of them has to be 0. Okay, so we know that. So yes, we can figure this out. Because all of these regions, so all 7 of these regions inside here have to add up to 150. So yes, we can figure this out. So we just add up all the regions. So this is 70. And then we have 70 plus this, which is going to be 145 minus x. And then 145 minus x plus x is 145. Okay. And then 145 plus 38 is 145. That gives 175, which is going to be 183. 183 minus x equals 150. Well, guess what? X has to be what? Think about it. It's just going to be a subtraction, right? You're subtracting off x. It has to be equal to 150. So you get what? You get a 183. So what do you get? You get 183 minus 150, and you get 33. X is 33, which means this is going to be 5, and this is going to be what? 12. No. 42. And we're done. Oh, one more thing. One last thing that I wanted to make a comment about. Oh, here. What do all these add up to? Add them up. What do they add up to? Well, you've got 20, 50, 57, 67, 70, 80, 90, 99. How many were supposed to be in his section? 100. This guy doesn't know how to count. We're going to demote him. And so instead of being a section leader, well, he's now going to be a meter reader for a night shift. He's done. Doesn't know how to count. Okay, that's it. Next time we'll start talking about one of my favorite topics, probability. Now, please make sure you go through each one of these examples. Also, try your hand at your turns for this section. And if you get stuck, please bring those questions to class. That's when I want you guys to be engaged. Hey, you get stuck on something? Bring it to class. Ask me about it. If you can't figure it out, bring it to class and ask me about it. We'll work it out on the board. That's what class is for. Okay, or you can email me, but work it out and get the practice in. Do the guided notes, fill them out, and then we can confirm and work on those and answer questions and practice in class. And so that way you guys do well on the exam. Until next time, have a great day.